Today I will be giving an overview of the digestive system with an emphasis on fat metabolism. We will start with a brief overview of the digestive system. Digestion is defined as the mechanical and chemical breakdown of food into components small enough to enter the bloodstream. The mechanical breakdown of food through chewing is actually the start of the digestive process. While your saliva moistens your food, enzymes contained in the saliva begin the chemical breakdown. The chewed food and saliva mucus combine into a ball that is called the bolus. When you swallow, the bolus is transported into the esophagus. Peristalsis is the wave-like contraction of muscle, which is effective in transporting the bolus through the esophagus and into the stomach. It takes food about 7 seconds after being swallowed to reach the stomach. Upon arrival of food into the stomach, special cells release hydrochloric acid, which increases the stomach acidity to a pH of 3. The acidic environment expedites the digestive process, while the stomach muscles mechanically churn the mixture. When food has been adequately digested in the stomach, it is ready to move on to the small intestine. Food paste that passes from the stomach to the small intestine is known as chyme. It is important to realize that until this point, no nutrients have been absorbed. They have just been broken down. The small intestine is the first place where nutrients are actually absorbed. In fact, the small intestine is responsible for 90% of nutrient absorption and digestion. A variety of organs aid in the small intestine's digestive process. The pancreas is an organ that is responsible for the synthesis and secretion of digestive enzymes. The liver is an organ that makes bile, which is used to emulsify fats in the small intestine. Bile is stored in the gallbladder. Following nutrient absorption in the small intestine, the digestive material passes to the large intestine, which is commonly known as the colon. The main purpose of the large intestine is to reabsorb water and electrolytes. Digested material is stored in the colon for 12 hours before it is ready to pass through the rectum and exit through the anus as stool. Now that we have a foundation on the basics of the digestive system, we can focus our attention on fat digestion and metabolism. The journey begins in the mouth with an enzyme called lingual lipase, which is located in the saliva. It hydrolyzes long-chain triglycerides into partial glycerides and free fatty acids. Although fat digestion starts in the saliva, the far majority of breakdown occurs in the small intestine. Bile and lipase enzymes mentioned before will further break down the remaining fatty acids into monoglycerides and free fatty acids. Free fatty acids will form micelles in the lumen of the small intestine. In this form, the hydrophilic heads are exposed while the hydrophobic tails are shielded from the surrounding aqueous solution. Micelles are transported to intestinal absorptive cells known as enterocytes. In this picture, the dark purple cells are enterocytes, and they are lining the intestinal villi. Once inside the enterocytes, fats are resynthesized back into triglycerides. Through the addition of apolipoproteins, cholesterol, and phospholipids, triglycerides are reassembled and modified to form chylomicrons. Chylomicrons have the liposome structure shown. You can see that they are similar in structure and function to micelles. Next, chylomicrons will enter the lacteal of the villi. The lacteal is the entrance to the lymphatic system. Chylomicrons will travel through the lymph until they reach the thoracic duct in the neck. It is here that chylomicrons enter the bloodstream. The apolipoproteins serve as signaling molecules and combine to receptors on muscle cells and adipocytes. These cells can release the enzyme lipoprotein lipase, which will hydrolyze the triglycerides into free fatty acids and monoglycerides. Muscle cells will use the fatty acids primarily for energy, while adipose cells will absorb free fatty acids in order to resynthesize them into triglycerides for storage. After the chylomicron has donated the majority of its fatty acids, the shrunken and degraded structure is referred to as the chylomicron remnant. It now contains mostly cholesterol. It is taken up by the liver and its components are recycled. A final subject to be briefly discussed in our overview of fat metabolism is the transport of cholesterol. Cholesterol is processed, transported, and absorbed by the liver. Cholesterol is transported via lipoproteins, similar to chylomicrons. LDL, or low-density lipoprotein, will carry cholesterol from the liver to the body. HDL, or high-density lipoprotein, will carry excess cholesterol from the blood back to the liver. HDL is referred to as good cholesterol because it lowers free blood cholesterol. Free cholesterol will accumulate in the blood vessels and cause elevated blood pressure and increased risk of heart disease. We will conclude the video by exploring modern research on the subject of fat metabolism. In a paper by Metabolism et al. 2013, the researchers explore the effects of an increased pancreatic lipase activity. As we have discussed, lipase secreted by the pancreas and present in the small intestine works together with bile to hydrolyze triglycerides into smaller components. These components are taken up by enterocytes of the villi and subsequently distributed and metabolized by the body's cells. The researchers discovered a naturally occurring inhibitor of pancreatic lipase. When the inhibitor was absent in mice, pancreatic lipase activity was increased. They measured these mice to have elevated fat mass and body weight. Their stool was analyzed and found to have low levels of lipids. In brief, the experiment showed how an increased activity of pancreatic lipase in the small intestine would result in increased fat absorption, metabolism, and weight gain.